Hey guys, welcome back to chapter 13. This will be the last video before we move on to kind of the mathematical half of this chapter. So last thing on kind of getting to know these equilibrium constants and K. So up until this point, I've given you one type of equilibrium, and that is homogeneous or homogeneous. It's when the equilibrium reactants and products are all in the same phase. So likely you didn't even consider or look at the phases. On some of them, I probably completely left it off. But that's what we've looked at so far. There is another type, heterogeneous equilibria, where reactants and products may be in more than one phase. So in this type of equilibria, it's important that we take note as to what the phases are, because that's going to affect the equilibrium constant K. So let's look at the following reaction here. Okay, so this would be an example of a heterogeneous. We've got calcium carbonate, which is a solid, produces carbon dioxide, which is a gas, and calcium oxide, which is also a solid. So this would be an example of a heterogeneous equilibria. The reason that we want to keep an eye on the states is because some of the states are not included in the K equation. For example, the concentration of liquids and solids doesn't change. So if you think about, like, I'm going to write the concentration of a solid into the K equation. Does that really make sense, right? We don't talk about concentration for solids. Liquids, so if we think about a liquid, what we're talking about there is a pure substance. So you're like, absolutely, we talked about concentration of liquids. No. We talked about concentration of solutions, namely aqueous solutions. When I'm talking about a liquid, I'm talking about a pure substance. So something like hydrogen peroxide, right? Or ethanol, okay? So pure ethanol, pure hydrogen peroxide, not mixed with water or anything. Now, those liquids do not change concentration. So we don't talk about the concentration of liquids. We don't talk about the concentration of solids. They are not included in the K expression, so not included in that equilibrium expression, okay? What is included? Gases are included, and aqueous is included. So two are in, two are out. So if I were to write the equilibrium expression for this particular equation, I would write it as such. K equals products over reactants. So products, I would include the carbon dioxide. I would not include the calcium oxide. However, if you would like to replace it with the number 1, just so your brain is like, hey, I acknowledge it's there, but I'm not including it, that would be fine. And then, so products over reactants, our reactant is also a solid. We also don't include that. So the K expression ends up being just the concentration of carbon dioxide. That's it. That's the equilibrium constant for this one. Okay. Looking at a couple other examples, so think about these two, and then I will pause the video, and then I will talk you through them. All right, so I'm just going to highlight the things that I would not include. So iron oxide here is a solid. That does not get included. And then iron here is a solid. That does not get included. Right? We don't talk about the concentration of a piece of iron. Right? That's kind of silly. So the K equation for this one would be just K equals concentration of products over reactants. So carbon dioxide over the concentration of carbon monoxide. That's it. And then same thing for this guy down here. Iron hydroxide is a solid, not included. These two are aqueous. They absolutely are included. So the K equation for this one would be products over reactants. So concentration of our iron ion times the concentration of our hydroxide, and that's cute. And then there's nothing on the reactant side to include, so I'm just going to kind of hold that place with a 1. So the K value for this would just be concentration of the iron ion times hydroxide. So that's it. There's going to be an equilibrium, heterogeneous equilibrium problem on your test. I'm going to say, write the K equation for the following, and you're going to be like, wow, this is like free points. So easy. But be careful. If it's too good to be true, it probably is too good to be true. So just keep an eye on the states for that question. If it's a question you're like, free points, wait, there might be a twist. There probably is a twist. It's probably one of these. Hope you guys found that helpful.